All right. Right. Logic gates, the last part in electronics, right? Logic gates, the last part and the easiest part in electronics. Huh? Digital is the easiest part we have in electronics, right? Digital circuits, logic gates, and flip-flops. The easiest part you got in electronics, right? So when it comes to both essays, MCQs, everything, that is the easiest type of questions you got. Right. First one, the logic gate which corresponds to the truth table shown is. That's a very popular one. No? Nothing to do. 0, 1, 1, 1 means this is the O gate. This is the O gate. Right. 0, 1, 1, 1 means, right, that's a very popular one. No? Right. This is the O gate. This is the O gate. Then O gate 3. Right. O gate, it is 3. Second one, in the circuit shown, ABC represents a binary. ABC represents a binary number for the output F. To be binary 1, ABC should be. Okay. Now, in such cases, it is easier to write this output first as a Boolean expression, right? Now, we know if this is A and B, right? If this is A and B, now after this AND gate, this is A dot B, no? And if this is B and C here, after this AND gate, this is B dot C. Then this is an OR gate, then F is A dot B plus B dot C, right? Now you can see B is common, take it out, then A plus C, right? This is the output, this is the output. Then in order to be this binary 1, then B should be 1 and either of A and C should be 1. B should be 1 and either of A and C should be 1. Then it's 5, no? Right? It's 5. It's 5. So likewise, check the Boolean, write the Boolean expression and check it out. That's the easiest way. Otherwise, don't try to apply these given combinations and check it 5 times. No way, right? No way. 3. If A, B, and C are 3 Boolean variables, the output F is given by. Okay. Then write the output. See, then here we know after this NOT gate, that is B bar, this is an AND gate. Then after the AND gate, what you are getting here is B bar dot C, no? This is an OR gate. Then final output is A plus B bar C. A plus B bar C, it's 1. A plus B bar C, it's 1. Right? Right, this is 4. 4. The gate shown in figure is equivalent to. Right. The gate shown in figure is equivalent to. Right? This is an AND gate, no? This is an AND gate. Right? NAND means not AND. Not AND means if a NOT gate is connected in front of an AND gate. Simple. If a NOT gate is connected in front of an AND gate, then there is 3. There is 3. Right? 5. The gate shown in the figure is equivalent to. What is given here is a NO gate. That's a NO gate. NO means not O, not gate in front of an O gate. Not gate in front of an O gate. Then there is 5. Then there is 5. Right? 6 is a question put mistakenly. That is an electricity question, no? Right? I think I discussed it in electricity. So I'm going to skip this. Right? I'm going to skip this because that is from electricity. Mistakenly put here. Right? 7. The second input of the gates shown in the diagram is connected to binary 1. Of the gates, performance are identical only. Right? Check the outputs. Check the outputs. Check the outputs. That's the only way out here. Then if this is A, after the NOT gate, this is A bar. After the NOT gate, this is A bar. See, after the NOT gate, this is A bar. Right here, this is an AND gate. Then A dot 1, no? Then this is A dot 1. A dot 1 means A again. A dot 1 means A. Right, this is an OR gate. Then there is A plus 1. 1 plus anything is 1. It is 1. Then in the fourth case, there is A plus 1 and its bar. A plus 1 is 1. 1 bar means 0. That is 0. Then last one, there is A dot 1 bar. A dot 1 is A, so that is A bar. Then in first one and the last one, there is A bar, no? Then P and T. P and T. 5. Right, there is P and T. 8. 8. 8 in the second answer, it should be from T0, T1 to T2. Second answer should be corrected as T1 to T2. Right. Figure shows a digital circuit. The variations of the logic values of the inputs ABC with time T are shown in figure B. The output X will be 0 during the time intervals. Okay. Write the Boolean expression. Time intervals apply karanne ba, don't apply time intervals first before you take the Boolean expression. Once you get the Boolean expression, then you can check against the expression. That is easier. That is way easier. Right? So get the expression first. Then this is an AND gate. Right? A and B are coming in. Then the output here is A dot B bar. And B and C are coming in here. Right? B and C are coming in here. Then the output of this one is B dot C bar. Then what about X? X is A dot B bar plus B dot C bar. Right? Now, you can simplify this a bit. So we know, let me write the simplification here. Question 8. Right. Then as X, what you have got is A dot B bar plus B dot C bar. No? Right? We can split the bar as A bar plus B bar plus here B bar plus C bar. Then B bar plus B bar is B bar. Then this is A bar plus B bar plus C bar. Right? This can be written using De Morgan's law again as ABC. Right? ABC bar. Right? This is ABC bar. Now my final Boolean expression here is ABC bar. My final Boolean expression here is ABC bar. Then the question is, X will be 0 during the time. X is going to be 0 if both are 1, 1, 1, no? Right? Because when ABC are 1, 1 dot 1 dot 1 is 1, 1 by is 0. Then time interval is from T1 to T2. Answer is 2. Right? So likewise, easily you can check when you have the Boolean expression. Go with the expression. 9. An alarm is to be sounded to a car at least when the car is started while the door is open. Car is started while the door is open. Right? Or the car is started while driver is not wearing seat belt. Three sensors ABC provide signals such that A equals 1 when at least one door is open, B equals 1 when the engine is running, and C equals 1 when the driver is not wearing seat belt. If the alarm is activated when F equals 1, the correct truth table for F is right. Okay. Then right, there are three inputs A, B, C, and output is F. Right. Then 8 lines 1, 2, 3, 4, 5, 6, 7, 8. Right. Right. Then 0, 0, 0, 0, 1, 1, 1, 1. Right. What happened? Second. Right here. Right. 1, 1, 1, 1. Right. Then B 0, 0, 1, 1, 0, 0, 1, 1. Now it's coming. Okay. Then 0, 1, 0, 1, 0, 1, 0, 1. Right. Right. First thing. Right. I'm going to decide on this F. First thing, if the engine is not on, no need to sound the alarm. No. Right. It is clearly given in the question. Right. If the engine is not on, no need to sound the alarm. Right. Then when B is 1 only, engine is on. Then when B is 0, no need of sounding the alarm. Then when B is 0, always the line F should be 0. Right. When B is 0, line F should be 0. No need to check again. Right. Now check the third line. Engine is running, but A and C are 0, which means door is closed and seat belt is worn. Then no need to sound the alarm 0. No need to sound the alarm 0. Then this case, engine is running, but C is 1, which means not wearing the seat belt. Then it should be sounding. Then it becomes 1. Right? It becomes 1. Then seventh line, 1, 1, 0 means engine is on, but the door is open. Alarm should be on. And final, engine is on, both are here, both door is open, right? Both instances, door is open and seat belt is worn, not worn, are satisfied, 1, right? Now menna truth table එක කෙලිම මේක check කරන්න. Right, that is in 5, right? That is in 5. 10. The circuit corresponding to the logic expression A dot B plus C, A dot B plus C, right? Just write it out. B plus C. B plus C means it should be coming through a B plus C bar. It should be coming through a NO gate, right? It should be coming through a NO gate. It should be coming through a NO gate, right? B, C, this is an O gate. Then this is B plus C. This is an AND gate. Then from here A comes A dot B plus C. So the answer is 1. Answer is 1. Simple as that. 11. Consider the following statements made regarding the logic gate shown in figure. Right. That's a simple AND gate. Okay. Then we know R equals, right? R equals P dot Q. R equals P dot Q. Right. Then when P equals 1, R equals Q. When P equals 1, it becomes 1 dot Q. No, 1 dot Q is Q. So A is correct. B, when Q equals 0, when Q equals 0, 0 dot anything is 0. Then Q cannot be, sorry, R cannot be P, that is wrong. C, when P is 0, R equals 0. Yes, because 0 dot anything is 0. It is correct. Then A and C. A and C. Right? 12. P, Q, R, this should be S, T, and U. S, T, U. Which of the two gates shown can be combined to construct a circuit in order to obtain a binary output of 1 for input binary digit combination 0, 0, and 1, 1. That 0, 0, 1, 1 homogeneous combinations, similar combinations are a special case we have, right? That's a special case we had that is coming in XO and NXO. That is coming in XO and NXO, right? Just check with the XO gate, right? The theory is the XO gate. Question number 11, right? Question number 11. Check with the XO gate, right? We know output of the XO gate is AB bar plus BA bar, right? Truth table lage matakai nan hodai, right? If not, just check the truth table, right? This is AB and F. See what happens in the XO. 0, 0, 1, 1, 0, 1, 0, 1. When 0, 0, right? Both A and B are 0, F is 0. When 1, 1, both A bar, B bar and 0, then this is also 0, no? Right? Second line, A0, B1 means, A0 means first term is 0, but B is 1, then A bar is also 1, A is 0, A bar is 1, then 1 comes. Here also 1 comes. See what has happened? When it gives, right, this is a special case for homogeneous combination. See, when input combination is 0, 0, it inputs 0. When input combination is 1, 1, it outputs 0, right? For 0, 0, it's 0. For 1, 1 also, it's 0. Now the question is about obtaining output 1, no? Then if a NOT gate is connected in front of this XO, right? Maybe an XO. This is an XO, right? This is an XO. See, this is an XO. This is an XO, right? This is an XO. AB, F. Now, if a NOT gate is connected in front of this XO, it is done because these zeros becomes 1. Then NOT gate is given as R, XO is given as U, then R and U. R and U. Right? It's 3. 13. Two NOT gates are connected as shown in figure. Consider the following combinations of logic levels for the outputs Q1 and Q2. Logic level Q1 and this is logic level for Q2. Q2. Which of the above combinations will provide a stable logic levels for Q1 and Q2 outputs? Stable means they should be valid without being invalid, right? They should be valid without being invalid. Then start with one argument. Assume Q is 0. If Q is 0, along this is 0. Then this is 1. If this is 1, see 0 and 1. This is also satisfied. The sides of the NOT gate, and this is 0 and 1 satisfied, which means now when Q1 is 0, Q2 becomes 1. No, that is a stable case. When Q1 is 0, Q2 is 1, stable, B is stable. Right? B is stable. B is stable. Right? Then similarly, C is also stable. C is also stable. Right? C is also stable. C is also stable. Okay, in patra check karat, same thing. right? If you check the vice versa also, it's same. See, if this is 1, right, up to here, that is 1, this becomes 0. If there is 0, this becomes 0. It's 1. But if you check for 0, 0, it is never going to get 0, 0, 1, 1 for Q1, Q2. That is never going to get 0, 0 and 1, 1 for Q1, Q2. Then they are invalid cases. Then answer is only B and C. Answer is only B and C, 5. Right, only B and C, 5. 14. Which of the arrangements shown is true equivalent to a NOT gate? Right, NOT gate. Then let's say this input is A. Right, if this is A, this is A, this is also A. Right, if only one input is inputted, right, always always the NOT function works. Right, if you don't know it, you can just simplify it and see. Right, but in the class we discussed. Right, if only one input is given for a gate which has two inputs, only the NOT function or the other function works, right? Then make a plus. See what happens. Now this F is, this is A plus A bar. A plus A is A, so that is A bar. That is A bar, right? Then similarly here also, if this is A, this is A dot A bar. No? A dot A is A, so that is A bar again. That is A bar again, right? And this is an XO. This is an XO, right? Say A and A, right? Then output of XO is since this space is not enough there, right? Output of XO is AB bar plus BA bar, no? Our usual output. Now there's no B, that is also A. Then what happens is A dot A bar plus this one is A dot A bar again. A dot A bar is 0. Then 0 plus 0 is 0. 0. Then in this case, this is 0. Not going to function. Not going to function. Right? Then if there is 0, right? If there is 0, NXO is also not going to function because NXO is going to be 1. NXO is going to be 1. I check NXO is going to be 1, not XO, no? Going to be 1. Then answers are only P and Q. Only P and Q. Right? Only P and Q. 15. Which of the following gates cannot have more than one input? That's a very popular case, right? There's only one input is possible for the NOT gate because NOT gate is actually a transistor functioning as a switch. NOT gate that's a transistor functioning as a switch, and VIN is given by the base. There's only one base for the transistor, NOT gate. Right? Which of the following gates cannot have more than one NOT gate? Right? Same question, 2011 new syllabus and old syllabus, 11, 12 mark case. Right? 17. Which of the logic circuits shown will operate in the following manner? Okay, then you better check with the Boolean output again, right? Here, Boolean output is, this is S and S bar, no? Then this is X dot S bar. In this case, this is X plus S. And in this case, this is, right? This is S bar again, that is X dot S bar bar. X dot S bar bar. This can be simplified. This can be simplified, no? This is X plus, X bar plus S, right? X bar plus S. Okay, check now. When S equals 0, output is X. When S equals 0, output is X. When S equals 0, C can be removed from that point itself because when S equals 0, output of C is going to be X bar, right? That is going to be X bar. Then C is not a possible answer. C is not a possible answer. C is not a possible answer. Right. C is not a possible answer. And for other two, when S equals 0, S bar becomes 1, then first one is satisfied. Correct. When S equals 0, second one is also satisfied. Go to second condition. When S equals 1, output is 0. When S equals 1, output is 0. Then for A, when S is 1, S bar is 0, it is satisfied. For B, when S equals 1, 1 plus anything is 1, that is not satisfied. So only possible answer is A. For 17, 1. Right? See, digital is easier. Don't miss these marks. Don't miss these marks. Right? 18. Consider the following statements made about the circuit shown in the figure. Okay, then write the output again. Write the output. Then this is I1. This is S means this is S bar, no? S bar. And this one is E. Then from here, I1 S bar E comes out. And from here, I2 SC comes. Then F final output here is, can you see that E is common? E is common. Then let me take E out. Let me take E out. E is common from the output, no? Then if E is taken out, I1 S bar plus I2 S, right? So this is the output of this circuit, no? See, this is the output of this circuit. This is the output of this circuit, right? See, this is the output of this circuit. Now, check with the given statements. Check with the given statements. Right. Output. Okay. Then when E equals 1, S equals 0 and output F equals I1. E equals 1. Okay. Then S equals 0. S equals 0 means I2S term becomes 0. Then S equals 0 means S by is 1. Then first statement is correct. Then F equals I1, no? Correct. F equals I1. Simplify करेगा. I2S is 0, then S by is 1, then I1 dot 1 is I1, right? E is also 1, then I1 dot 1 again is I1. So A is correct. B, when E equals 1 and S equals 0, the output is I2. That's also correct, no? See, S equals 1 means S by 0. That term is gone. Then S equals 1 means I2S becomes I2 dot 1 I2. Then I2 is I2, I2 dot 1 is I2 into E is 1. That is I2 again. B is also correct. See, when E equals 0, the output F equals 0 irrespective of the values of S. That is correct, no? Because E is E dot, the other thing is there. Then if E is 0, the whole thing becomes 0. If E is 0, whole thing becomes 0. All A, B, C are correct. All A, B, C are correct. 19. A and B shown below represents the logical inputs applied to circuits 1 and 5 given below, and F represents the expected output from the circuit. Which of the following 1 to 5 provides the expected output? Okay. Right. Then just check with these outputs. For the first one, output is A bar dot B. No? For the second one is an XO. Then AB bar dot BA bar. AB bar plus BA bar, right? And this is an NXO, that is AB bar plus BA bar whole thing bar. Right? This is an OR gate, A plus B, right? And this is an AND gate, A dot B. Right, now check with these outputs, that's it. Right? Time intervals, check around. You can start from time interval 1 and check for like 2, 3, 4 time intervals, then you will get the answer. Right? Otherwise, now here like 20 time intervals are given. Right? When you check like first 2, first 3, first 4 maximum, you can finalize something. First time interval, all are 0, no? All are 0. All are 0. Right? A and B are all means A and B are 0, then output is 0. A and B are 0, output is 0. Then when A and B are 0, output is 0. It is satisfied by all except 3, right? It is satisfied by all of them except 3. Then 3 එක නම් දැම්මම remove කරන්න පුළුවන්. 3 is strong. 3 එක එන්නේ 0 0 දැම්මොත් 1 කියලා. Right? Second one, A equals 0, B equals 1. If A equals 0, B equals 1, see, the first one becomes 1, no? A equals 0, B equals 1 means this one becomes 1. Then in the output there is still 0. This cannot be a possible answer. This cannot be a possible answer. Right? And about XOR gate also, if A0, B1 is applied, it becomes 1. So it cannot be a possible answer. Then second one, right? Sorry, fourth one. A0, B1 means that is 1. That is also 1. That is also gone. Then it must be 5. See how easy? Right? On third day check kala third day 0 0 again 0. Fourth one A1 B1. A1 B1 means F is 1, right? So it is 5. 20. P, Q and R represent the binary input variables applied to the given circuits ABC. Okay. When outputs F1, F2 and F3 of the circuits for given combinations are considered, right, same outputs. Then write the output. Write the output for the first one. From here P comes. From here Q plus R comes. Then this is P dot Q plus R. No? That is P dot Q plus R. Right? Output is P dot Q plus R. For the second one, right? From here, P dot Q comes. From here, P dot R comes. Then F2 is P dot Q plus, this is an OR gate. Then P dot Q plus P dot R. P dot R. P dot R. Now you can clearly see P is common, then Q plus R. Right? Now first two are correct. Second, third one. Third check now. Check the third one also. Check for the third one also. Then this is P. Right here, this is Q plus R. Q plus R bar. This is 1. Then the output here is 1 dot Q plus R bar whole thing bar, no? Because that's an AND gate. 1 dot anything is same, which means this is, let me simplify this a bit. This is Q plus R double bar, no? Right? Q plus R double bar means Q plus R. Then in Q plus R. Then from here P comes, this is an AND gate. Now again this is P plus P dot Q plus R. Same. All are same. Then all three circuits give the same output 4. Right? All three circuits give the same output 4. 21. Which of the following gates operate according to the truth table given? Right. So directly given truth table is a NOT gate. Right? When A equals 0, F is 1. A equals 1, F0, that's a NOT gate. So P is obviously correct. No need to check again and again. If you check for Q, 5 volts means 1. Na? As a binary, 5 volts means 1. Then for this one, this is actually A dot 1. No? A dot 1 means A. That is not a NOT gate. So Q cannot be an answer. Then check for this one. This is an XOR gate. This is an XOR gate, right? So we know output of XOR is AB bar. Right? Output of XOR is AB bar plus BA bar. Right? Now this is like B and this is given as 5. 5 means 1. 5 means 1. Then simplify. A dot, this is 1 bar plus B means 1. No? Then B is 1 dot A bar. 1 bar is 0. Then this term becomes 0. 1 dot A bar is A bar. Then A bar comes. Then R is also correct. Then PNR 4. Right? PNR 4. 22. Two digital voltage waveforms A and B shown are connected to the two inputs of the gate shown. The correct output voltage waveform is, right, simple. Right? They are A and B. This is an OR gate. Then there is A plus B. Right? Output is A plus B. Right? The output is A plus B. Right? Output is A plus B. Right? Then A plus B. 0, 0 means A plus B becomes 0. 1, 1 means it is 1. Again 0, 0 means it is 0. Again 1, 1 means it is 1, 0. 1, 0 is again 0. 1, 0. 1 plus 0 is again 1. Right? It's 1. Right? When you check like 3, like first 3 or first 4 maximum, can finalize. 23. The logic circuit shown in the figure A is equivalent to. Okay. First simplify the output and check whether it's a known output. Then AB. Then from here A dot B comes out. Right? And from this B bar comes. From this A bar comes. Then from here A bar dot B bar comes out. Then output here is A dot B plus A bar dot B bar. No? Right? This is the output. A dot B plus A bar dot B bar. That is not a familiar one. Right? We know output of AND gate is A dot B. Wrong. Right? Output of OR gate is A plus B. Wrong. Output of NAND gate is A dot B bar. Wrong. Output of XOR and NXOR are there. They are two special ones. You better check. And about XOR also, I'm not going to check because and worry because we know about XOR. See, about XOR, you know, output of an XOR gate is AB bar plus BA bar. No? Right? XOR, EXOR, you know. right? AB bar plus BA bar, right? It is completely different from what I have got. Then I'm going to check with NXO. See, output of NXO. NXO, output of NXO is AB bar plus BA bar, whole thing bar, right? Simplify this, simplify this. Now, if this bar is split, what we get is A dot B bar bar dot B dot A bar bar, De Morgan's law, right? And then split the bar inside again, then it becomes A bar plus B, and here B bar plus A. Simplify this, simplify the brackets, huh? Then A bar dot B bar plus second term A bar dot A plus B dot B bar plus B dot A, right? We know A dot A bar is 0. Similarly, B dot B bar is also 0. Then here what we have got is A bar B bar dot, sorry, plus AB. A bar dot B bar plus AB. That's the same output here, no? A dot B plus A bar dot B bar. මේකත් ඒකනේ A dot B plus A bar dot B bar. Same. Then answer is 5. So likewise, now remove the known and the popular ones and check with the other unknown ones. That's easier. Right, 24. Logical inputs A, B, and C of the given circuit is shown below. Right, the shape of the correct output is okay. Then get the Boolean expression again. A, B means now you are getting A dot B here, right? And C here. Then output is A dot B plus C. No, output is A dot B plus C, right? First 4 time intervals again බලන්න මම කලින් කිව්වේ. When all are 0, answer is 0. When all are 0, answer should be 0, right? In the second case, A is 1, B is 0, C is 1, which means output is 1. Then second time interval should be 1. Now I have the try between these two only. Then third time interval, A0, B1, then there is 0, then C is also 0, then it should be 0. It should be 0. It should be 0. Then third time interval should be 0. Right? In both, it satisfies. Then about the fourth time interval, 1, 2, 3, 4. 4. A is 1, B is 1, C is 0. Then A dot B is 1. No? 1 dot 1 is 1. Output is 1. It should be 1 again. 4 again 0. Then it is 2. Answer is 2. Right? 25. For 25, the diagram is not given here. It is this, right? This diagram should come under 25. It is missing in this copy, right? This diagram should come under 25, right? This diagram should come under 25, right? Then the given circuit is equivalent to it, right? If only one input is given, only the not function will be function, right? If only one input is given, only the not function will be function. Only the not function is function. But only the not is function. If this is x, this is like x and x, right? Then what you are getting out is, right, this is x dot x bar, no? X dot x is x, that is x bar, not gate. Right, 26. Which of the following can store 1 bit of data? 1 bit of data. That's a very popular and a unique scenario. That's a unique scenario, right? The only device in digital we have a memory. Only device we have a memory is flip-flop. And right, gates all ran. Then remove all gates. Only device we have in electronics with a memory, right? With a memory is flip-flop. That's a flip-flop. And 1 bit means it can recall the immediate previous step only. Only one bit in the memory. It can recall only the immediate previous step only. Right? Only the immediate previous step. Right? So that's the flip-flop. Right? So that's it. Right? That's it. And now I have discussed, right? All the questions we had in electronics also, right? I have discussed all the questions we had in electronics also, right? And I will be publishing this as 4 different videos, right? I will be publishing this as 4 different videos. Today I'm recording this on Monday. Monday means 10th of August. I'm recording this on 10th of August, and I'll be publishing this as 4 different videos, right? Then practice these questions again and again, and check your answers and build up your confidence and face the exam well, right? So I hope this would be a help when you are going to the exam, and all means most of other past paper discussions are also available under S2A playlist, right? Most of the past paper discussions are available, MCQs, and structure essays are also there, and provincial and support seminar paper discussions are also there under S2A discussions. So you can go through them. You can go through them and familiarize yourself with these things and face the exam well, right? All right then. Then that's it. Goodbye. See you.